A Boeing 787-8 cruise speed is 490 knots, not 905 kilometers per hour, not 564 miles per hour. The aviation industry commands a global infrastructure whose annual economic impact is estimated by the International Air Transport Association to be in the hundreds of billions of dollars. Yet its core velocity vector relies on a non-metric unit. Kilometers and statute miles are designed for flat surfaces. They are arbitrary segments. A statute mile is 5,280 feet. This number was finalized in England in 1593 as a compromise to reconcile the Roman mile with local agrarian measures of length. The meter, approved in France in 1791, was anchored to the size of the planet, defined as 1/10,000,000th of the distance from the equator to the North Pole. But the kilometer remained a linear scale. On planetary distances, flat linear notations complicate navigation. The Earth is an oblate spheroid. The planet's circumference is divided into 360 degrees, and each degree into 60 minutes of arc. Due to the Earth's ellipticity, the length of 1 minute of arc along a meridian varies from 1,843 meters at the equator to 1,862 meters at the poles. To standardize these discrepancies, the International Hydrographic Conference in 1929 fixed the conventional nautical mile at exactly 1,852 meters. This is the averaged step of the planet's coordinate grid. 1 knot is a speed equal to 1 nautical mile per hour. If an aircraft flies at 60 knots strictly along a meridian, it shifts by exactly 1 degree of latitude in 1 hour. Long-distance navigation is calculated via the orthodrome, the Great Circle Arc. Using kilometers or statute miles does not alter the computational complexity of algorithms inside flight management computers. However, using nautical miles allows the crew to match linear distance with angular coordinates on navigational charts without additional scaling calculations. The knot is a tool designed to simplify the operational interface between humans and the coordinate grid. Non-standardized units of altitude and speed cause catastrophes. On April 15, 1999, a Korean Air MD-11 heavy trijet crashed in Shanghai. The crew was instructed to climb to 1,500 meters, but misinterpreted the system units, confusing meters with feet on the instrument panel. This interface reading error led to a loss of control, the destruction of an $80 million airframe, and the deaths of 8 people. In 1948, the Council of the International Civil Aviation Organization adopted Annex 5, aimed at the unification of units. The metric system was approved as the primary standard. However, knots, feet, and nautical miles were retained as temporary exceptions. This compromise is driven strictly by safety. A simultaneous replacement of instruments and standards across thousands of active aircraft created a critical risk due to human factors. In ultra-high-density traffic, a 300-meter mix-up means an instant exit from a safe flight corridor directly into the path of an oncoming flight level. The knot is not an anachronism. It is the operational language of navigation adapted to the physical parameters of the planet. We use it because long-distance trajectories are governed by the geometry of a sphere. The knot links the machine's speed and the planet's coordinate code into a single applied system. Linear meters are not equivalent to angular coordinates. Speed on a sphere requires spherical parameters. Subscribe for systems, not stories.